Hello viewers, welcome to my channel Maths with the VTC. Today we are going to see arithmetic progressions. Arithmetic progression is nothing but a sequence of numbers which follows a certain pattern. In real life we come across with many sequence of numbers. Arithmetic progression is very simple and interesting to study. Let us see some real life situations where we come across with the sequence of numbers. Reena applied for a job and got selected. She has been offered a job with a starting monthly salary of rupees 8,000 with an annual increment of rupees 500 in her salary. Her salary for the first, second, third years will be respectively 8,000, 8,500, 9,000 and so on. It is a sequence of numbers. You can see each term is obtained by adding 500 with the previous term. So that is the pattern followed in the sequence of numbers. Next example. The length of the rungs of a ladder decrease uniformly by 2 cm from bottom to top. The bottom rung is 45 cm in length. The lengths of the first, second, third rung from bottom to top are respectively. Before see the numbers, let us see the diagram of the ladder. You see the bottom rung is lengthy and the topmost rung is comparatively smaller in length. So the numbers will be 45, 43, 41, 39 and so on. Because from the bottom, each rung is reduced by 2 centimeters. So here you have a sequence of numbers which follows a certain pattern. What is that? Each number is obtained by adding minus 2 with the previous number. That is the pattern followed here. Okay. Now let us see the third example. In a savings scheme, the amount becomes 5/4 times of itself after every 3 years. The maturity amount in rupees of an investment of rupees 8,000 after 3rd year, 6th year, 9th year and so on will be respectively 10,000, 12,500, 15,625 and so on. If you look at the sequence of numbers carefully, from 10,000, 12,500 is obtained by multiplying 10,000 by 5/4. Similarly, 15,625 is obtained by multiplying 12,500 by 5/4 and so on. So, each number is obtained by multiplying the previous number with the 5/4. So, that is the pattern followed in the sequence of numbers. Next example. The number of unit squares in squares with the sides 1 unit, 2 unit and 3 units and so on are respectively 1 square, 2 square, 3 square and so on. Let us see the diagram. So first you have only 1 square. Second, length is 2 units, therefore 2 square, that is 4 squares are there. The next square is of length 3 units. Therefore, 3 into 3, 3 square, 9 unit squares are there. So, it will go on continuously. So, now you can easily understand the pattern in the sequence of numbers. Okay. So, 1 square, 2 square, 3 square. You can guess the next number. 4 square. Next number will be 5 square. So, you can easily guess. This is an example. Shakila puts rupees 100 into her daughter's money box when she was 1 year old and increased the amount by 50 every year. The amounts of money in rupees in the box on the first year, second year, third year, fourth year birthdays were, you can guess, first 100, then 150, then 200, then 250 and so on. You can easily guess the pattern in this sequence of numbers. Next, this is a very interesting example. A pair of rabbits are too young to produce in their first month. In the second and every subsequent month, they produce a new pair. Each new pair of rabbits produce a new pair in their second month and in every subsequent month. Assuming no rabbit dies, the number of pairs of rabbits at the start of the first, second, third, and 6th month respectively are 1, 1, 2, 3, 5, 8 and so on. Actually, this is called a Fibonacci sequence. Yeah, first you have 1, next 1, Those two numbers are added to get the third number. Again, second number and third number are added to get the fourth number. Third number and fourth number are added to get the fifth number, and so on. So it is a very famous sequence of numbers called Fibonacci sequence. Now let us see the diagram of rabbits. So first month you have only one pair. Second month also you have only one pair. Third month you have a new pair. So in total you have two pairs. Fourth month you have three pairs, and fifth month you have five pairs, and so on. You can easily understand this diagram. If you read the paragraph carefully, you can easily understand this. Okay. Now arithmetic progression. So far we discussed a certain sequence of numbers. Few are arithmetic progression. Now let us restrict ourselves only to arithmetic progression. Let us see some examples for arithmetic progression. So first 1, 2, 3, 4, 5, 6 and so on. It is an arithmetic progression. 100, 70, 40, 10 and so on. This is also an arithmetic progression. -3, -2, -1, 0 and so on. 3, 3, 3, 3 and so on. -1.0, -1.5, -2.0, -2.5 and so on. All these are arithmetic progressions. Now you look at all the sequence of numbers carefully, you can understand the pattern followed by all these sequences. In all the lists above, we see that successive terms are obtained by adding a fixed number. Remember that fixed number can be positive or negative or even zero to the preceding terms. Such a list of numbers is said to form an arithmetic progression. Each of the numbers in the list is called a term. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. The fixed number is called the common difference of the arithmetic progression. Remember that it can be positive or negative or even zero. Let us denote the first term of an arithmetic progression by A1, second term by A2, nth term by An, and the common difference by D. These are all universal notations. Therefore, A2 minus A1 is equal to A3 minus A2 is equal to An minus An minus 1 is equal to D. So, common difference of an arithmetic progression can be obtained by using any one of these formulas. Some more examples of arithmetic progression are the heights of some students of a school standing in a queue in the morning assembly are 147, 148, 149 and so on to 157. B. The minimum temperatures recorded for a week in the month of January in a city arranged in ascending order are -3.1, -3.0, -2.9 and so on. These are all given in degrees Celsius. So this is also an example of an arithmetic progression. C. The balance money in rupees after paying 5% of the total loan of rupees 1000 every month is 950, 900, 850, 800 and so on, because every month 50 rupees reduced. Next, the cash prices in rupees given by a school to the toppers of class 1 to 12 are respectively 200, 250, 300, 350 to 750. The total savings in rupees after every month for 10 months when rupees 50 are saved each month are 50, 100, 150, 200 and so on. So these are all easy examples for an arithmetic progression. The general form of an arithmetic progression. A plus D, A plus 2D, A plus 3D and so on. This represents an arithmetic progression where A is the first term and D is the common difference. This is called the general form of an arithmetic progression. If there are only a finite number of terms, such an arithmetic progression is called a finite arithmetic progression. If there are infinite number of terms, such an arithmetic progression is called an infinite arithmetic progression. If you know the first term A and the common difference D, then you can write the arithmetic progression uniquely. So if you are given the first term and the common difference, then you can easily write the corresponding arithmetic progression. Examples. A is equal to 6, D is equal to minus 3. The arithmetic progression is 6, 3, 0, minus 3, minus 6 and so on. So it is an infinite arithmetic progression. A is equal to minus 7, D is equal to minus 2. The arithmetic progression is minus 7, minus 9, minus 11, minus 13 and so on. Each term you have to add by minus 2 to get the next term. 1.0, that is A. D is equal to 0.1. The corresponding AP is 1.0, 1.1, 1.2 and so on. A is equal to 0, D is equal to 1.5. So 0, 1.5, 3, 4.5, 6 and so on. A equal to 2, D equal to 0. This is a peculiar arithmetic progression because it is a constant sequence 2, 2, 2, 2 and so on. In general, for an arithmetic progression A1, A2, An, we have D is equal to AK plus 1 minus AK, where AK plus 1 and AK are the K plus 1th and Kth terms respectively. So arithmetic progression D can be obtained by giving any particular value for K in this formula. D is equal to AK plus 1 minus AK. Therefore, A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 is equal to D. So it is very simple. Let us see problems now. Example 1. For the arithmetic progression 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2, write the first term A and the common difference D. Solution. So in this given arithmetic progression, A is equal to 3 by 2 and D is equal to second term minus the first term. Half minus 3 by 2 is equal to minus 1. You can consider third term and second term also. Third term minus second term will give you the same answer, minus 1. Example 2. Which of the following list of numbers form an arithmetic progression? If they form an arithmetic progression, write the next two terms. 4, 10, 16, 22. Obviously, A is equal to 4. The first term is 4. Common difference is 6. You can easily guess. Therefore, the next two terms are 22 plus 6, 28 and 28 plus 6, 34. So, you can easily solve this simple problem. Next, 1, minus 1, minus 3, minus 5 and so on. So, you can find the common difference. A2 minus A1 is equal to minus 2. A3 minus A2 is also minus 2. A4 minus A3 is also minus 2. To ensure that the common difference is minus 2, I consider the possible 3 pairs. Therefore, common difference is minus 2. To find the next term, next two terms, you have to add minus 2 with minus 5. So, minus 7. Again, next term, minus 7, minus 2, minus 9. Third problem, minus 2, 2, minus 2, 2, minus 2 and so on. So, when you find A2 minus A1, it is equal to 4. But A3 minus A2 is equal to minus 4. Therefore, this is not at all an arithmetic progression. Let us leave this. Fourth problem, 1, 1, 1, 2, 2, 2, 3, 3, 3 and so on. So, this also you can easily guess that you will not have the common difference is same. Therefore, it is no longer an arithmetic progression. Thank you viewers for watching this video. Let us meet in the next video.